So this is the continuation of lecture 2, part 1. And now we are going to look at departmental planning. Departmental planning. Planning departments can involve production, support, administrative, and service areas. Production planning departments are collections of workstations to be grouped together during the facility's layout process. Depending on the product volume variety, production planning departments can be classified as product, fixed materials, location, product family or group technology, or process planning departments. So we have these three classifications, and in this figure, figure 9, shows how or when to use one of these three production planning department strategies: product, fixed materials or product family, or process planning. And the decision is based on these two factors: the volume, how many products you are going to be producing, and the variety in terms of the products that you produce, how many different type of products. So for instance, if we look at a process in which the variety is very low and the volume is very high, then the product planning department or product layout will be a better strategy for designing your departments. On the opposite side, if we have a low volume and a high variety, then process layout will be a better strategy for you. If both of them are low, then the fixed location layout, like for example, if you're producing a airplane, so volume is low, variety is low, so you most likely are going to be bringing everything to the location to put together that airplane. And then in the middle, we have the product family planning department, in which we have a variety that is medium and volume is also medium. The procedural guide for combining workstations in planning departments. So these are guidelines that can allow you to make decisions in terms of which workstation should be in a particular department. So we start with the finding out if the product is standardized and has a large stable demand. If that's the case, then the type of planning department should be the production line or product department. And the method of combining workstations into planning departments should be combine all workstations required to produce that product. So you want to have everything there. On the other side, if the product is physically large, awkward to move, and has low sporadic demand, as we discussed in the previous slide, like an airplane, fixed materials location or product department should be used. You combine all workstations required to produce a product within or with the area required for staging the product. Then if the product is capable of being grouped into families of similar parts that may be produced by a group of workstations, like the cell phones, Samsung example, product family or product departments is the type of planning department that should be used, in which, and the method of combining workstations into the planning department should be combine all the workstations required to produce the family of products. So if you have one family, then you are going to combine all the workstations that are needed for that family. And you have a separate family, then you have another group of part of machines or stations that are combined for that family. If there's not, if your product is not following any of those three classifications, then you want to do a process department that combines identical workstations into initial planning departments and attempt to combine similar initial planning departments without obscuring important interrelationships within departments. So for product family departments, or PFD, aggregate medium volume variety parts into families based on similar manufacturing operations or design attributes. So this is, we go back here, product family departments are here in the middle. So the machines required to manufacture the part family are grouped together to form a cell, thus the label cellular manufacturing. The direct clustering algorithm that we are going to discuss next methodology is a simple procedure that clearly illustrates the important features of the cell clustering problem. So we want to group these departments, or we want to identify these departments or cells, and we want to know which station should be in each of the cells so we can produce families separately. The direct clustering algorithm is based on a machine part matrix in which 1 indicates that the part requires processing by the indicated machine, and a blank indicates, white space indicates the machine is not used for the particular part. So in this slide, we have the DCA algorithm, or the direct clustering algorithm methodology, and these are the steps. So in step 1, we order the rows and columns, and once we have the matrix, we sum the ones in each column and in each row of the machine part matrix, and then order the rows top to bottom in descending order of the number of ones in the rows, and then you are going to also order the columns left to right in ascending order of the number of one in each. Where tie exists, you're going to break the tie in descending numerical sequence. Step 2, sort the columns, beginning with the first row of the matrix. Shift to the left of the matrix, all columns having a 1 in the first row. Continue the process row by row until no further opportunity exists to shifting columns. Step 3, now we are going to sort the rows column by column, beginning with the leftmost column. You are going to shift rows upward when opportunities exist to form blocks of ones. Performing the column and row sortation is facilitated by using spreadsheets such as Microsoft Excel. In step 4, we're going to form cells. We're going to look for opportunities to form cells, such as all processing for each part occurs in a single cell. So don't get scared. It's not, it's actually very simple to implement. So next we are going to discuss an example. So in this example, we want to apply the direct clustering algorithm method to group 5 machines. Okay, so these are the 5 machines. We have them listed at the top: 1, 2, 3, 4, and 5. And then we have in this company, we have 6 different parts that we manufacture. Okay, so 1, 2, 3, 4, 5, 6. These parts are, the parts are always to the left right? So we list them to the left, and then the machines will be at the top. And then a 1, what that means is, like for example, this one means that part 1 is processed by machine 1. So in this case, part 1 is processed also by machine 3. And then part 2 is processed also by machine 1, only by machine 1. Part 3 is processed by machine 2, machine 4, and machine 5. Part 4 is processed by machine 1 and machine 3. Part 5 is processed only by machine 2. And part 6 is processed by machine 4 and machine 5. So the first thing that we want to do, step 1, we want to sum the ones in each row and in each column and in each row of this matrix. So that's what we are doing here. So you will see that for each row, there's a total. So 2 is 1 by 1, 1 plus 1, then 1 plus 1 plus 1 is 3, 1 plus 1 is 2, then 1, and then 1 plus 1 is 2. And we did the same thing per column, 3, 2, 2, 2, and 2. So having the matrix and having the totals for each row and for each column, then we proceed to the next part of step 1, which says order the rows. So these rows, we're gonna order them in descending order of the number of ones in the rows. So what that means is we're gonna sort the rows and we're gonna put the ones at the bottom and the highest values at the top. So order the rows top to bottom in descending order of the number of ones in the rows. And then for the columns, so in this case, we want to start with 3, 2, and 2, and 2, and then 1 and 1. That's the orders that we want to create. And then for the columns, we are going to order the columns left to right in ascending order. So in this case, we want to start with 2s, 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 and then 3. So those are the movement that we have to do. And then if we have ties, we're gonna break the ties in descending numerical sequence. So for example, for all these 2, then I'm going to start with machine 2, machine 3, machine 4, and machine 5. And then put machine 1. Okay, so you break the tie by the number of the machine. Same thing for the parts. You break the ties by the part number. So on the next slide, we are going to apply that first step that I just mentioned. So applying step 1 of the direct clustering algorithm, the rows are ranked in descending order of the number of ones. So that's what happened here. So now we have part 3 at the top, followed by 6, 4, 1, 5, and 2. So the ties were break by giving priority to the highest values. And then for the columns, the same thing. We start with the 2. Now we want to order the columns in ascending order. So we break the tie with the highest value. So ties are broken in descending numerical sequence. The row order sequence of the part numbers is 3, 6, 4, 1, 5, 2. Likewise, the columns are arranged in ascending order of the number of ones, with ties broken in descending numerical order. So the resulting column order sequence of the machine's numbers are or is 5, 4, 3, 2, and 1. So if we look at the original order, the original order was 1, 2, 3, up to 6. Same thing here at the top, 1, 2, 3, up to 5. And after reordering that based on the rules of the algorithm, we get this matrix. So 5 was moved to here, 1 was moved here. Step 2 involves sorting the columns to move toward the left. All columns having a 1 in the first row, which represents part 3. Since the column for machines 5 and 4 are already located to the left of the matrix, only the column for machine 2 can be shifted. So originally, this was the location of the 1, right? So we start with the top row, and we are trying to shift the ones towards the left. So we need to move this column to the left, and that's what happened here. So 2 was moved to the left. And then we go to the next row, and we check if we can shift any other 1 here. Remember that this is fixed, this is fixed, this is fixed. So we are basically looking to shift 3 and 1 now. When we move to the next row, we notice that there's a 1, and we have found, and we know that 3 is already in the right position, and 1 as well. So at that point, we don't have any other, so we fixed 3 and 1. So there's no other movement that we can do for the rows towards the left. Step 3 consists of sorting the rows by moving upward rows having a 1 in the first column that are not already located as far toward the top of the matrix as possible. Since none can be shifted further for either machines 5 or 4, the first row to be moved is that for part 5 based on its processing requirement with machine 2. So if we go back to this, now for step 2, we were looking at the rows, and we were trying to move to the left. For step 3, we are looking at the columns, and we are trying to move upwards. So we start with 5. Okay, this one is already at the top. This one is already following this. So we are fixing this and this. Nothing else here in this column, nothing else. So we move to column for 4. Then same thing, nothing can be moved. They're already at the top, so there's nothing else here. And then we move to the next one. We have one, there's first one at the top, and there's another one here that can be shifted towards the top. So now we are gonna move 5 to here. Because remember, 3 and 6 are fixed already. So that's what's happening here. When we move that to the top, and then we continue with the process. So we shift 5. Now we have this resulting. So we look at 4. Actually, we look at this column 3. This cannot be moved anymore. So this fix, fix, fix. So for 4, this is the higher that you can go. So you're in the right place. Same thing here, nothing here. And then we move to the next column. Same thing, you are located the highest you can go. So at this point, we have completed step 3. So step 4 asks us to form cells. Look for opportunities to form cells such that all processing for each part occurs in a single cell. Okay, so if we go here and we look at this matrix, can we separate the machines per part type? Like for instance, we can here break this matrix in 2 parts, and we know that there's no overlapping between, for example, these 3 parts are produced by these 3 machines, and these 3 machines, 5, 4, 2, are not needed to produce these 3 parts. So in that way, we know that we can separate these 2 groups into families, and they can be produced on separate cells. So parts 3, 5, and 6 being processed in a cell made up of machines 2, 4, and 5, and with parts 1, 2, and 4 being processed in a cell consisting of machines 1 and 3. Okay, so that's the answer. Okay, we have 2 cells, and we can say cell 1 will have machines 5, 4, and 2, and will produce 3, 6, and 5, and then the second cell will have machines 3 and 1, and will produce parts 4, 1, and 2. The second example is to illustrate the case in which you don't have a clear split, and what to do when that's the case. So using the direct clustering algorithm method to determine alternative groupings of machines. So this is the original matrix, and providing you with the answer to illustrate the point. So suppose that applying the direct clustering algorithm methodology results in the following order machine part matrix. So this is the answer after applying DCA. So now we want to try to split this into cells. But notice that because machine 2 is needed for parts 3 and 5, there's a conflict. So you will say, okay, I can try to split this, let's say, like this and this, but then we need machine 2 to produce part 3, so that's not an option. So 2 cells can be formed, one consisting of machine 4 and 5, one consisting of machine 1, 2, and 3. The machining required for part 3 of machine 2 needs to be resolved. So how do we work with this machine that is needed for both cells? This machine is needed for part 3 and also is needed for part 5. So what do we do? If we try to split it in a different way, we still have the same problem. What if we include 2 as part of the first cell, which is what's happening here? We still have a conflict. This machine is needed in both cells. So the machine of part 5 or machine 2 must be resolved. So one way to solve this problem, and this is what I call solution 1, if machine 2 and 3 can be located relatively close to one another in different cells, then part 5 could be processed by machines on the boundaries of the cell. So that's one way to do it. We can somehow create two cells, one this way, one this way, and then we can put that machine that is needed by both cells kind of in between. Another option is to duplicate machine 2 and place it in each cell. So in this case, you will have two machines. So two machines of type 2, which is what we are illustrating here by 2A and 2B. So in that case, you have, by duplicating the same machine, you have one of them in one cell and the other one in the other cell. Okay, so that concludes the discussion on the direct clustering algorithm method for product families. Now we move to layout types based on material flow systems. So the type of material flow system is determined by the makeup of the activities or planning departments among which materials flow. As noted previously, there are 4 types of production planning departments: production line departments, fixed material location departments, product family departments, and process departments. So on the next few slides, I'm going to show you the advantages and disadvantages or limitations for each one of the layouts. So here we have the production line product layout, in which you have basically manufacturing lines that are composed of different stations, and then you move each product based, you produce one type of product in each manufacturing line. So the advantages: smooth, simple, logical, and direct flow lines results. Small working process inventories should result. Total production time per unit is short. Material handling requirements are reduced. The total production time per unit is short because you are limiting the setups, right? So this production line will never change, or each one of those are not changing. So there's no setup in terms of reconfiguring the line. Less skill is required for personnel because, again, the location of the machines and the type of machines are always fixed. Simple production control is possible. Special purpose equipment can be used. The limitations, like if something happened to the machine, one of those machines, that the production will stop the line. That machine will stop the production. Product design changes cause the layout to become obsolete. So if you have a new product coming in, then you need to change the production line. Slow station pace the line. General supervision is required, and higher equipment investment usually results. Then we have the fixed product layout. This is like what I mentioned, the airplane, that everything comes together in the same location. So you're bringing the production to that location where you're assembling the product. Advantages: material movement is reduced. When a team approach is used, continuity of operations and responsibility results. Provides job enrichment opportunities because employers need to get familiar with all operations. Promotes pride and quality because an individual can complete the whole job. Highly flexible, can accommodate changes in product design, product mix, and product volume. The limitation: personal equipment movement is increased, may result in duplicate equipment, requires greater skill for personnel, requires general supervision, may result in increased space and greater working process, and requires close control and coordination in scheduling production. The product family layout, and this is the type of layout that you can build using the direct clustering algorithm. So here again, you have products family. So let's say this cell is used for one product. This is another cell that can be used to manufacture another part, and so on. So what are the advantages? By grouping products, higher machine utilization can result because you are producing different type of products continuously. Smoother flow lines and shorter travel distances are expected than for example, process layouts. Team atmosphere and job enlargement benefits often result. Has some of the benefits of product layouts and process layout. It is a compromise between the two. Encourage consideration of general purpose equipment. Some of the limitations include the general supervision is required. Greater labor skills required for team members to be skilled on all operations. So if you are part of this cell or this cell, you are required to know how to operate all these machines and also to perform the assembly. If flow is not balanced in each cell, buffers and working process storage are required in the cell to eliminate the need for added material handling to and from the cell. Has some of the disadvantages of product layout and process layout. It is a compromise between the two and decreased the opportunity to use a special purpose equipment. And then we have the process layout. In this one, things can move where they're needed. Like you see here, you can go from here to here, and this guy can go here, and then this guy can go here. So there's no a structure, basically. The advantages is like, since you can allocate jobs to any of the machines, there's an increase in machine utilization. General purpose equipment can be used, highly flexible on allocating personnel and equipment, diversity of tasks for personnel, specialized supervision is possible. The limitation is that there's an increase in material handling requirements. As you can see, there's like spaghetti there, so there's a lot of movement going on. More complicated production control required, increased working process, longer production lines, higher skills required to accommodate diversity of tasks required. Okay, so that concludes this lecture 2, part 1. And these are the items that we discussed. Introduction, the flow system, the material flow system, departmental planning, and the layout typeface of material flow system.